Hi everyone, this is Katie Hoeberling, and today I'll be talking about a life cycle assessment project focusing on almond processing and transport in California. So life cycle assessment is a tool that's used by industrial ecologists and allows them to quantify the impacts of various production systems, whether those are environmental or health related. So if you've ever heard of an ecological footprint, a carbon footprint, or a water footprint, those usually come out of LCAs, and they can track inputs such as energy use, water, and other materials, and then outputs such as greenhouse gas emissions and emissions of other chemicals and particulate matter, physical waste, that kind of thing. And then these outputs and inputs as well can be measured in terms of their impacts, so global warming potential, human toxicity, eutrophication, and other potentials. So California's almond industry is a huge industry. It made $5.77 billion last year. It's the highest grossing specialty crop in California, and its production accounts for 860,000 productive acres, so this is the second highest after hay production. The grant that this project is funded by is from the Almond Board of California, and they focus on working with different farmers, processors, and distributors of almonds in California to promote sustainability of the supply, industry-wide food safety regulations, and to enhance production. And some of you, actually probably all of you, know about AB 32, which is the Global Warming Solutions Act. So this requires California to reduce its greenhouse gas emissions to 1990 levels by 2020, and it's implemented by the Climate Action Team. So this is made up of actors such as the California EPA, the Air Resources Board, among others, and these institutions will regulate actors such as processors through emissions limits and fees for over-emitters. And it also establishes the cap and trade market. So there's potential in this life cycle, the almond life cycle, for producers and processors to auction off carbon credits from carbon sequestration in orchards or cogeneration from shells, and those are mechanisms I'll talk about later on in the slideshow. So for this almond LCA, our goal is to quantify energy use and emissions of greenhouse gas emissions and criteria air pollutants from the California almond processing and distribution industry. And we are building on previous research which focused on production and the hulling and shelling processing, so that's the first step in processing. Our functional unit is 1 kilogram of in-shell almond kernels, and this is useful for comparing between different stages in the almond life cycle as well as between different agricultural products. Another goal we have is to provide processors, handlers, and consumers with a better understanding of the environmental impacts of the industry, and we'll ideally try to find hotspots within facilities as well as along the supply chain where actors who want to focus on energy efficiency or emissions reductions improvements where they can focus. So here is a general overview of the almond processing industry. So as you can see on the left, raw almonds from harvest will come in and they'll be hulled and shelled. This is the first step in the processing process. And then if they are to be sold on the domestic market, they'll be pasteurized either with propylene oxide or steam. And if they're to be sold on the international market, they don't have to go through that. They'll just go straight to finishing processing. So that's your slivering, slicing, salting, blanching, and roasting. And then they'll be distributed either through trucking, by rail, or by ship if they're to be sold internationally. And as you can see, a majority of California's almonds are sold internationally. And the way that we have planned to model transportation is using GIS and data that we will collect using surveys regarding major points of entry. So we've already done some background research and literature reviews of major processing processes, and we've developed a survey that we hope to be supplemented by guided tours of facilities in California. And our goal is to develop an inventory that may be made available for future LCAs. Some major processors you might have heard of that we plan to survey are Paramount and Blue Diamond. Another aspect of LCAs is co-product allocation. So in the almond life cycle, hulls, which are basically the fruit that come right off the tree, the almond kernel is the seed which is inside the hull. These are removed and they can be sold as dairy cattle feed. So because they are allocated towards cattle, water inputs and other inputs can be diverted away from cattle production. So this is something that we'll need to quantify eventually, and in order to do this, we'll need to know the water requirements for California hay production, water requirements for almond production, and the ratio of hulls to hay feed requirements for dairy cattle. So for that, we'll need to consider nutrition and energy requirements of the cattle, and the dairy production potential, so that relationship to feed intake. And this will have implications for regional water managers because hay and almond production are the two highest acreage crops in California, and both are irrigated. So my two questions for you are, what kinds of impacts does life cycle assessment attempt to quantify? And how are California's almond and dairy industry related in terms of their impacts on water use and climate change? All right, thank you.